So the chemical system will be at equilibrium when the rate of the forward reaction is equal to the rate of the reverse reaction. So the reaction is occurring in both directions at the same rate, just like the cars on the freeway. Well, what does a rate of a chemical reaction mean? We know what rate of speed is, right? Rate of travel. How many miles per hour? Well, in terms of a chemical reaction, we're measuring how fast the reaction proceeds, and that's usually measured by the amount of reactant that changes to product in a given amount of time. So it could be, 5 moles react per second. We're not actually going to quantitate this. We're not going to talk about an actual rate. We're just going to talk about relative terms. We also need to understand what affects the reaction rate. What would make a reaction go faster? What would make it go slower? So we have to talk about collision theory. And this is a theory that helps us to understand how and why reaction rates change as they do, instead of just stating how they change. So collision theory takes the view that chemical reactions occur through collisions between molecules or atoms. So in order for two molecules to react, they have to run into each other. That kind of makes sense. How can they react if they're on opposite sides of the beaker? So they have to run into each other, and that collision must occur with enough energy for the reaction to proceed. The collision energy is going to be related to particle velocity. So, the same thing as, two cars colliding. The collision is worse. There's more energy in that collision if they're going faster than if they're going slower. So when the particles collide, if they're moving faster, they're going to have more energy when they hit. In the gas phase, molecules have a wide distribution of velocities. Some of them are moving very fast, some of them are moving very slow. The average velocity corresponds to the temperature, but some are high and some are low. Higher energy collisions lead to products, low energy collisions don't. So it's a little bit like meeting someone and having chemistry occur, right? You get involved with each other. You have to actually meet each other one way or another, and there has to be some sort of a spark. There has to be some energy when you meet, right? If you're just kind of bumping into each other, passing in the hallway, and you don't even really notice each other, you're not going to end up getting married, right? It's just not going to happen. Most chemical reactions have what we call an activation energy. It's this energy barrier that you have to get over before the reaction can proceed. And the activation energy is often the energy needed to break existing bonds. So if we think about this example of hydrogen reacting with iodine to form hydrogen iodide. Well, these two hydrogen atoms have a bond that holds them together, and the iodine atoms have a bond that holds them together in the molecule. In order for this reaction to occur, we have to break both of these bonds. That's going to require some energy. So when these molecules collide, there has to be enough energy on that impact to break the bond, otherwise they're just going to bounce off of each other. We observe that the factors that influence the rate of a reaction are the same factors that affect how many high energy collisions occur in a given unit of time. So one of the factors is concentration. The rate of reaction increases with increasing concentration because higher concentration means more collisions. Where are you more likely to meet people? In a crowded nightclub or out in the orchard? In the nightclub. Why? Because there's more people there, right? You can't meet people if there's nobody there, right? If you've got this huge place with only a couple people in it, the chances of meeting are very slim. Same thing for molecules. If there's a lot of them crowded together in a small volume, they're going to bump into each other a lot more. And so that increases the chances of having collisions. So that increases the rate of the reaction. So if we look at what's happening here, so this is low concentration is going to have a low rate. Intermediate concentration, intermediate rate. High concentration, high rate. But what happens is, as the reaction proceeds, the rate's going to decrease. So if you think about, I don't know, maybe one of those speed dating places, right? And you've got all these people wanting to be part of a relationship. You've got a decent chance of meeting somebody there, right? So as people meet each other, they pair up and they go off and talk together. Their reaction has occurred. Now there's fewer reactants present. The concentration of people is going down. Does that make sense? As people are taken out of the picture, there's fewer for you to meet and your chances go down. As this reaction occurs between the hydrogen and the iodine, the concentration decreases. Decreasing concentration means decreasing rate of reaction. Temperature affects rate of reaction as well, because the temperature affects how fast the particles are moving. If they're moving faster, you're going to have more high energy collisions. Remember, there's this threshold. You have to have a certain amount of energy for a reaction to occur. At a higher temperature, you have more collisions that have enough energy, and so the reaction is higher. You also have more collisions. Because the particles are moving around faster, they're going to bump into each other more. So, summary, reaction rates increase with increasing concentration of reactant. They increase with increasing temperature. And as the reaction proceeds, they're generally going to decrease because you're running out of reactants. The concentration goes down. So, let's look at this. In a chemical reaction between two gases, you would expect that increasing the pressure of the gases would probably increase the rate, decrease the rate, or not affect the rate. So think about what increasing the pressure of a gas does. So how could you increase the pressure? You could make the container smaller, right? That's one way to increase the pressure. What does that do to the concentration of the gas molecules? It makes it higher, right? You've got more particles in a smaller area, or more smart. Yeah, look at those guys, those heads. They're just staring at me, gathering my thoughts. You have a higher concentration of particles, and so the answer should be increase the reaction rate. So increasing the pressure of a gas increases the reaction rate because you are essentially increasing the concentration of the gas.